Hello everyone. In this video, we are going to study the laws of indices, which is a very important topic in IGCSE Mathematics. Before we start applying the laws, let's first understand what an index actually means. An index or power simply tells us how many times a number or a variable is multiplied by itself. For example, here a is multiplied by itself 3 times. So the index or power is 3 and it is written like this: a raised to the power 3. Here a is called the base and the 3 is called the power. Similarly, here x raised to the power 4 means x being multiplied by itself 4 times. So here x is the base and 4 will be the power. In the next example, we have 2 raised to the power 6. That means 2 is multiplied by itself 6 times. So 2 is the base and 6 will be the power. In the next example, we have y multiplied by y multiplied by y. So y is being multiplied by itself 3 times, hence y raised to the power 3 or y cubed. Here y is the base and 3 will be the power. In the next example, we have 10 multiplied by 10 multiplied by 10 105 times. Can you guess what will be the answer? It will be 10 raised to the power 105. Here 10 is our base and 105 will be the power. For the next example, we have a multiplied by a multiplied by a multiplied by b multiplied by b. So we have 3 a's and 2 b's. That means a is being multiplied by itself 3 times, and then we have b multiplied by itself 2 times. So we will write a cubed into b squared. That gives a cube into b squared. Next example, we have x being multiplied by itself 3 times, y being multiplied by itself 2 times, and a z. So we have x raised to the power 3 multiplied by y raised to the power 2, and then we have a z. Z raised to the power of 1. Why? Because we have only one z present in the expression. So we have x cube, y square, and z. The power 1 need not to be written specifically or explicitly. Whenever we have a number and the power is not mentioned, we assume that the power will be 1. So before we move to the actual laws of indices, make sure you are comfortable with the idea of indices and what they stand for. Okay? Now let's look at our first law. When the bases are the same and we multiply, we add the powers. See, here we have a raised to the power m, and here we have a raised to the power n. In both the terms, we have the base as a. So the base is same and we are multiplying. So here I am keeping the base and then I have added the powers. So a raised to the power m multiplied by a raised to the power n will be equal to a raised to the power m plus n. We need to add the powers. Let's take few examples. Here we have x raised to the power 5 multiplied by x raised to the power 3, right? So here the base is x in both the terms. So I'll keep the base x and then I add the powers. 5 plus 3 gives 8. Okay. Next example, I have a cube that is also written on the slide, you can see. Then I have a raised to the power 7 and then I have a raised to the power 10 and I am multiplying all three terms. So what will I do? I can see that here the base is same. So I'll keep the base and then I will add the powers. When I do that, I get a raised to the power 3 plus 7 is 10. 10 plus 10 gives 20. So a raised to the power 20 will be the answer. Now, next question, we have 2x squared y multiplied by 3xy raised to the power 4. Okay, so let's see how we can solve this question. We can write this as 2 into x squared into y multiplied by 3 into x into y raised to the power 4. So let's multiply the numbers first and then I will deal with the variables. So the numbers here are 2 and 3. 2 multiplied by 3 gives 6. And then I have x squared and I have a x here. Then I have y and then I have y raised to the power 4. Alright. Now look carefully here. I have x raised to the power 2 and then here I have x raised to the power 1. Alright. So here the base is same. So I will keep the base and then I will add the powers. So I will write 6 into x 2 plus 1. In the similar way, here I will write y 1 plus 4. Why? Because here the power is 1 and the base is same. So I'll keep the base and I will add the powers. That will give me 6x cube into y raised to the power 5. Finally, the answer will be 6x cube and y raised to the power 5. Okay. So now let's do the next question here on the slide. I have 7 raised to the power 5. Okay. Then I have 7 raised to the power 9, 7 cube and 7. Again, very easy. All the base are same. So let's keep the base and then add the powers because we are multiplying. Okay. Add all the powers. I have 5. I have 9 plus 3 and plus 1. Do not forget about this. There is a 1 there, right? I already mentioned that 1 can be raised as power to any number and that number will not change. Okay. So now add them up and we will have 7 raised to the power 5 plus 9 is 14 plus 3 is 17 plus 1 is 18. So 7 raised to the power 18 will be the answer. Alright. Moving on to the second law. The second law says that when bases are the same and we divide, then we subtract the powers. There is a difference here that we need to identify. In the previous law, we were multiplying, but now here we are dividing. So now the powers needs to be subtracted. Look carefully here. Here I have a raised to the power m, as you can see, and then I am dividing it by a raised to the power n. Okay, so the bases are same. I have a as the base, so I'll keep the base and then I will subtract the powers. Why? Why am I subtracting? Because I am performing the operation of division. It's not multiplication anymore. Okay, you can write this expression in a different way. A raised to the power m divided by a raised to the power n in a fractional form, and the answer would be the same, a raised to the power m minus n. So let's take a few examples. Here I have x raised to the power 5 divided by x raised to the power 2. Again, the base is x in both the terms. So keep the base as it is, keep the base x, and then subtract the powers. We have 5 and then we have 2. 5 minus 2 gives 3. So the final answer is x raised to the power 3. In the second example, we have 8 raised to the power 20 divided by 8 raised to the power 15. Again, we have the same base 8. We are performing the operation of division. Keep the base same as 8 and then subtract the powers. So 20 minus 15 is 5. So 8 raised to the power 5 will be our answer. All right. So this is a question that I want you to try on your own. If you wish, you can pause the video and try it. Okay, so let's see how we can solve this question. Here we have 6 into a raised to the power 5 divided by 3 into a raised to the power 3. What I can do here is that I can write 6 divided by 3, and then I can multiply it by a raised to the power 5 divided by a raised to the power 3. That is the same thing. I have here separated the constants and the variables, right? So I can always do that. That does not change my expression. That is just a way to rewrite the expression actually. So 6 divided by 3, that is very easy. 3 divides 6 and that will be 2. And here you can see that I have a raised to the power 5 divided by a raised to the power 3. That is nothing but a raised to the power 5 divided by a raised to the power 3. That is a different way to write the same expression. So I will write 2. Since the base is again same a, I will keep the base and then I will subtract the powers. So that will give me 2 into a. 5 minus 3 gives 2. So 2 into a squared is 2a squared. All right. Now let's move to the next law, the third law, that is quite interesting, power of a power. So it says that when a power is raised to another power, we multiply the indices. We multiply the powers. See here we have a raised to the power m. Let me write it again for you. A raised to the power m. Here a is our base and m is the power, right? Now again what am I doing here is that I am raising a power of n to a raised to the power m. Okay, so that is the definition of power of a power. So whenever we have terms like these, what we will do, we will keep the base and we will multiply all the powers. So m and n will be multiplied together. That gives a raised to the power mn. Alright, let's take a few examples. Here we have x raised to the power 3. Look carefully, we have x raised to the power 3 and then we have whole raised to the power 4. Right? So x raised to the power 3 and all raised to the power 4 can be written as x 3 into 4. So the final answer would be x raised to the power 12. I just multiplied all the powers. Let's take this very interesting example. Here we have 3x raised to the power 4 y cubed and all raised to the power 2. So the interesting thing to learn from here is that the power outside the bracket applies to everything inside the bracket. You can see the power 2 here that is present outside the bracket, right? This power 2 will be applied to everything that is inside the bracket. Let me show you how. First, let me rewrite the question again for you. We have 3 x raised to the power 4 y cubed whole raised to the power 2. This power 2 will be applied to everything that is inside the bracket. So 3, let's take 3 and apply this power 2 to it. Then we have the sign of multiplication. We have x raised to the power 4 and let's apply the power. Then put another multiplication. We have y cubed, right? Then put this power on it. So everything that we had inside the bracket, this power will apply to everything. So 3 squared is 9. Now, here we have x raised to the power 4 and all raised to the power 2. That is power of a power. So power of a power will get multiplied. So that will be x raised to the power 4 into 2. Again, we have y cubed all raised to the power 2. Again, power of a power. What will we do? We will take y and then we will multiply the powers. That is 3 into 2. That leaves us with 9 into x. 4 times 2 is 8. Y 3 times 2 is 6. That is 9 x to the power 8 and y raised to the power 6. Alright. Here I have a similar question that I'm not going to solve. I want you to give your best attempt It's a easy question, and you can solve this by pausing this video and comment your answer, and I will tell you if you have arrived at the right answer or not. Now let's talk about zero indices. Any non-zero number raised to the power 0 is equal to 0. So any number that you might think of, like 25, 25 raised to the power 0 is 1. You may say, what about 100? So 100 raised to the power 0 is also 1. What about negative 1 divided by 4? What about it? Negative 1 divided by 4 raised to the power 0 is also 1. So any number that is not 0, if you raise the power 0 to it, it will give a value 1. However, 0 to the power 0 is undefined. Okay, so never say 0 raised to the power 0 equals 1. That is not true. Here we have an interesting example for you. We have a raised to the power 4 and all raised to the power 0. That is power of a power, something that we just learned. So power of a power, we keep the base and we multiply the powers. So a 4 multiplied by 0 is 0. A raised to the power 0 is 1, given that a is not itself 0. So as long as a itself is not 0, a raised to the power 0 is 1. Okay. Now let's talk about negative indices. A very common mistake students make is thinking a negative index means a negative value. It does not. A negative index means reciprocal. A raised to the power minus n becomes 1 over a to the power n. That is very important. That is the definition of negative indices. A raised to the power minus n becomes 1 over a raised to the power n. Let's take few examples. Here we have x raised to the power minus 3. X raised to the power minus 3 means 1 over x raised to the power plus 3. See the next example. We have 6 raised to the power minus 2. 6 raised to the power minus 2 means 1 over 6 raised to the power plus 2. That is 1 divided by 36. In the third example, we have y raised to the power minus 5. It simply means 1 over y raised to the power 5. The last example is very interesting. We have 1 over 7 raised to the power minus 4. Let's first talk about 7 raised to the power minus 4. 7 raised to the power minus 4 is nothing but 1 over 7 raised to the power 4. Alright. Now, if you put the values of 7 raised to the power minus 4 as 1 up divided by 7 raised to the power 4 here, it will become 1 divided by 1 divided by 7 raised to the power 4. From here, we are dividing by a fraction here. Alright, so I can write this as 1 into 7 raised to the power 4 divided by 1, that gives 7 raised to the power 4. So next time, whenever you encounter these types of fraction, remember that a negative power in the denominator comes up and becomes positive. I will repeat it again. A negative power in the denominator comes up and becomes positive. Let me give you some other examples. Let's say I have 1 divided by 10 raised to the power minus 6. This is nothing but 10 raised to the power 6. What about 1 divided by 32 raised to the power 5? It is simply 32 raised to the power plus 5. So this is how we will tackle negative indices. In this video, we learned what indices mean and we studied the most important laws of indices. In the next video, we will apply these rules to exam level questions exactly like those you will see in the IGCSE papers. Make sure you practice these rules before moving on. Thank you so much for watching. See you in the next video.